Welcome to Engage Math, Lesson 16, Problem number 2, where we are applying our knowledge of exponential growth and decay to real-world applications. So this formula right here at the top of the page is something that you can find on the inside back cover of your Engage Math workbook, and it refers to the fact that we could figure out how much of a quantity we have left at the end of a certain amount of time based on how fast it's growing or decaying. So you'll see what I mean as we work these three examples through. Let's start with the first one. So the population of Springfield grows by 3% each year. So I'm going to zoom in so you can see really well what the formula is and read the problem really clearly. So the Y is the final amount. So the final amount that we have is going to be equal to our initial amount, which is represented by A, and then 1, either plus or minus the rate of growth or decay. So if something is growing or increasing, it's a plus R. If something is decreasing or depreciating, it's minus R. R is going to be always written as a decimal. And then T is the amount of time at which we have something that's either growing or decaying. So now, let's kind of get started with the population of Springfield growing by 3% per year. So I already know then in the parentheses, we're going to have 1 plus 0.03. 3% means 3 out of 100, which is the same as this decimal right here. You could always, since you have a calculator for this, you could always do 3 divided by 100 and get this decimal. The initial amount of the population was 12,000. And we are looking for our final amount. So I'm just going to call it A for the final amount. And the number of years that the population was growing for was from 2010 to 40, which means 30 years. The great news is you can now just enter this right into your calculator, and you have 12,000 times the quantity 1 plus 3 100ths, or sometimes referred to as 0.03, but technically it's 3 over 100. Raised to the 30th power. And what you should get when you enter all that into your calculator, rounded to the nearest whole number, is a population of 29,127 people. Okay, let's go to B. So you're not going to see that formula up there anymore, but we're going to look at the problem and you'll know what it is because it's the exact same thing we did in the problem above in A. So this time we know the final amount. The car is currently worth $9,051.59. So that's the final amount that we know. We're trying to figure out what the initial amount was. So I'm going to use the variable P for our initial price. If we were investing money, the P is usually used, refers to the principal. But P is a good letter to use as our variable here, which is what we're solving for. So the initial price would have been multiplied by depreciation, meaning it's going down by 15% each year. So it's going to be 1 minus, we could either do just 0.15 or just 0.15, but we know that that's really 15 100ths. And this time, our time amount is 6 years. Now notice that the rate of growth or decay has to match up with the time in the same unit. So in other words, this is how much it's decaying or depreciating per year, and this number is the number of years, 6 years. Okay, we'll see that in the next problem where instead of years, they're talking about months. Okay, so what we're going to do now is I'm going to start by just rewriting this as $9,051.59 is equal to P. And on the calculator, if you do that 1 minus the 0.15, you're going to get 0.85, which again, we know is 85 100ths. And I would raise that on your calculator to the 6th power, which is going to give you some decimal. And it's going to be, I'm just going to write it right here, 377. There's a decimal point right here, 1495. But on your calculator, most calculators, there's great ways to be able to save that without having to write out that whole decimal, but we want to keep things pretty exact. So now I'm trying to solve for P. So now I'm going to change the color so you can see what we're doing, but I'm going to divide both sides by the decimal, the 0.3771495. If I do that to both sides, that will cancel. And on the calculator, it's great if you could just keep that stored in your calculator. But when you do that, you should get as a final answer that P is equal to this number, which is actually going to be 24,000. And in this case, that means that the initial price that you paid was $24,000. Or not you, but Jackie. I'm giving you a car, but it's Jackie who owns the car. Okay, let's go to letter C. All right, so notice that this again is going to be the same concept in that same formula. So this time we have our final amount, A, is equal to the 22 pounds that we originally started with, because that's how much plastic is used by the average person every month. That's a lot. And what we're going to do is it's going down because people are committing to trying to be a little more environmentally friendly. So we're going to do 1 minus 4 out of 100. So I'm going to make it 0.04. And we're doing this for 1 year. But since the rate of decay or the rate of decrease is 4% each month, we have to make sure that we use not 1 as our time, but 12, because the rate of decay or the rate of decrease is monthly, so the time has to be in months as well. And now you can just type that right into your calculator, and you should get, rounded to the nearest tenth, 13 and 5/10 or 13.5 pounds. Great. I'm going to zoom in on everything again so you can see everything on one page as you sign off. And great job. Thanks for joining us in Engage Math.